Hello, and welcome to this tutorial on how to use the Heatmap GIS Excel VBA app. Note that this app is available to the public at the link shown. Maps like this 1650 map of a section of Ukraine may portray information beyond the name and location of geographic features. For example, this map tells us something about the types of habitations included on the map. The habitation symbols used on this map can be used to estimate population density. Here, population density in 17th century central Ukraine. The purpose of the Heatmap GIS Excel VBA app is to create heat maps using information extracted from maps. The purpose of this tutorial is to show you how to use this app. But first, we must describe what a heat map created by this app is showing. Right off the bat, note that the Heatmap GIS app generates heat maps in KML file format for display by apps such as Google Earth. The heat map examples provided here are all opened in Google Earth. Zooming in on a portion of a typical heat map displayed in Google Earth, what we see are habitations shown on the map being used to create the heat map, and grids that represent the estimated population density of the region covered by the grid. The main question to address here is how population density is calculated for each grid. Now, the map example we are following shows several types of habitation, including Christian colonies, Christian villages, and Christian fortresses. For the heat map application, the various habitation types found on the maps being studied are entered by the user, and the user assigns a habitation weight in the range of 1 to 5 for each habitation type. Here, these weights represent relative population levels. So here we are saying that a Christian urban center has 5 times as many people as a Christian village. The result is that urban centers have 5 times more influence on the heat map than do villages. Note that these weights are arbitrary and are totally up to the user. So here this village has a population weight of 1 and the fortress has a weight of 5. To calculate the population density of a particular grid, we need to take into account the population weights of all of the habitations in the vicinity of the grid. Here is the equation that the Heatmap GIS app uses to calculate population density of a grid. As we just mentioned, the grid population density depends on the weights of all habitations, with habitations closer to the center of the grid having more influence than habitations far away. But before proceeding, we need to examine what effect grid range has on the calculation. How this works is that a large value of grid range means a greater influence of distant habitations. So large grid range values tend to smooth out a heat map at the expense of detail, as we will show shortly. Now we can get on with explaining how the Heatmap GIS app works. The first thing to note is that everything happens on the app's control sheet. For this tutorial, you can ignore the input data sheet. The next thing to note is that all of the yellow cells are the cells where you will input your heat map parameters. The green cells are filled in by the app after the app finishes building the heat map. You can check the results of the build to ensure that the results make sense for your heat map. Moving on, the first set of application inputs is self-explanatory, but let's dive into a typical input file. For this example input file, note the subclass attribute. This is the attribute that the app will use to calculate grid population density. So for this example, whenever the app finds a habitation in the input file with a particular subclass value, the app uses the associated population weight when calculating grid population density. Here, every Christian village habitation in the input file gets a population weight of 1. To finish up this section of the app control sheet, here are the 3 things about the input file that the app needs to know. In addition to the application type, the app needs to know the name of each habitation and a unique ID assigned to each. Next, you need to tell the app how big you want your grids to be and what grid range you want to use for the grid population density calculation. To provide some extreme examples, here is a heat map using a grid range of 2 kilometers for a grid size of 5 kilometers. And here is a grid range of 5 kilometers for a grid size of 5 kilometers. As mentioned, a larger grid range tends to smooth things out, but at the expense of detail. Regarding longitude and latitude maximum and minimum limits, leaving any value blank causes the app to include all habitations along the associated dimension. So here we have no limits and have used all habitations to create the heat map. But here we have placed limits on all dimensions, which limits the number of habitations used to create the heat map. Note also that we have reduced the grid size, which produces this more detailed heat map of the region with high population density. Moving on, grid transparency controls transparency of the resulting KML file when displayed in apps such as Google Earth. Feature scale factor determines the size of the features shown on Google Earth. So far, we have been looking only at the heat map grids, but turning on features reveals the habitations used to generate the heat map. The size of a habitation icon is determined by the habitation weight and the feature scale factor, where larger habitation weights and larger scale factors produce larger icons. Finally, icon colors correspond to habitation weights, so a large red icon indicates a fortress habitation. Let's finish up with some details. Here is a section of an input file which shows 2 entries that have the same ID values. These are the same place shown on different maps. But we only want the place to be counted once when creating a heat map. The Heat Map GIS app takes care of this by automatically deleting entries with duplicate ID values. So for this example, the input file has 3,463 entries, but only 2,553 unique entries, indicating that about 900 duplicate entries were eliminated. This is why the app needs to know which input file attribute is the unique value that it will use to eliminate duplicates. The example input file also has an entry with a ruin subclass. But the app is not looking for ruins and selects only entries with the subclass attribute symbol values provided by the user. Moving on, The app accepts input files in CSV, XLS, TXT, and ODS formats, and produces files in KML format. If you don't provide file paths, the app defaults to the current directory. The map name and map author are embedded in the output KML file. If the map name and/or the map author are left blank, default values are provided. And the app will verify that you want to write over an existing output file. Be aware that if you are generating a large heat map, it will take some time for the app to run, so be patient. If invalid entries are found, appropriate error messages should appear and the app should halt gracefully. If the app encounters an error that it can't recover from, it will provide some clue as to what the problem is. Here, for example, selecting a small grid size with no limits on latitude and longitude produced an out-of-memory error. Best to close down, attempt to correct the error, and rerun the app. Consider contacting the author as a very last resort. When a non-recoverable error does occur, you might want to check the input datasheet to see if it conforms to the app requirements. This tutorial has used data for 17th century Ukraine to illustrate how to use the heat map GIS app. But if you'd like to learn more about how we use the app to estimate population density of this region, check the links below. So that's how you use the heat map GIS Excel VBA app. The app can be accessed at the link shown here. Thanks for watching, and hopefully you will find this tutorial and the app useful.